In this video, we'll be finding the maxima and minima of a quadratic function. The maximum or minimum value of a quadratic function occurs at the vertex. If your parabola is pointing up, you have a positive leading coefficient, then your parabola is going to have a minimum value, but not a maximum value. Since a parabola facing up goes to positive infinity, we can't say specifically, oh, this number is the maximum value, because it's going all the way to infinity. Similarly, when your leading coefficient is negative and your parabola is pointing down, this time we're going to have a maximum value at the vertex, but no minimum value, because a parabola pointing down is going to negative infinity. Note that the maximum or minimum value of the function is the y value of the vertex. So let's find the minimum or maximum value of the quadratic function. And this is going to be the y coordinate of the vertex. Unfortunately, we can't just go right to the y coordinate of a vertex when our quadratic function is in general form. We have to first get the x coordinate of the vertex and then plug it in to get the corresponding y coordinate. I anticipate that this quadratic function is going to have a minimum value since it is a parabola that is opening up. The x-coordinate of our vertex is negative b divided by 2a. So that's negative 4 over 2 times 1. It's going to be positive 4 over 2, which is 2. But this isn't the minimum value. To get the minimum value, we need the y-coordinate of the vertex. So let's plug 2 into our function and get our minimum value. F of 2 is 2 squared minus 4 times 2 plus 5. So that's 4 minus 8 plus 5, which is 1. We say that we have a minimum of 1 at x equals 2. There are many applications that can be solved using this technique of finding maximum and minimum. The height s in feet of a rocket after t seconds is given by the formula s of t equals 192t minus 16t squared. We want to find the maximum height of the rocket. Anytime the application problem is asking for the maximum and your function or equation is quadratic, you're looking for the vertex. In these application problems, you really need to read through them to determine whether you're finding the x or y coordinate of the vertex. If it's just like a problem before where it's not an application and you're just given a function and asked to find the minimum or maximum value, it's always the y. But in these applications, you have to read through and look at the context. They're asking us to find the maximum height of the rocket. So we need to determine whether s or t represents the height. The first line says the height s. So we're looking to maximize s. And then if you turn your attention to our function, s is over here by itself where y usually is. So we are looking for the y coordinate of the vertex. There's no way to go directly to the y-coordinate of the vertex. We're going to have to find the x-coordinate first and then plug it into our function to get the y-coordinate. The first thing I would do is I would rewrite my function in descending order so I didn't accidentally grab the wrong number to plug into my vertex formula. I would rewrite this s of t equals negative 16 t squared plus 192t. The x-coordinate of the vertex is negative b divided by 2a. That's negative 192 over 2 times negative 16. It's negative 192 over negative 32, which gives us 6. Now, technically, the variable here is not x. Technically, it's t, but in our mind, we're thinking x-coordinate of the vertex. Now we need to find the corresponding y value. This is going to be s of 6. It's negative 16 times 6 squared plus 192 times 6. It's negative 16 times 36 plus 1,152. Negative 16 times 36 is negative 576 plus 1,152. We get 576. And since it's an application problem, we need to make sure that our answer makes sense for the context, that we've answered the question and included any units. Does the answer of 576 make sense for the height? Well, sure it does. It's not super high, but maybe it's a kid in a field shooting off a rocket and not NASA. So, yes, as long as we get a positive answer, that makes sense for the height. We want to make sure that we've answered the question. They asked us to find the maximum height. That's the y-coordinate of the vertex, and we found that. And then the last thing we need is to include any units, and we were told that the height is in feet. Our final answer is 576 feet. Let's try another one. We want to find two numbers whose difference is 18 and whose product is a minimum. Well, I'm going to start by getting my thoughts organized on the side. We have these two numbers. So I'm just going to call it first number and second number. They didn't tell us specifically what either number was. They only told us that the difference is 18. Well, since I don't know what the first number is, I'm just going to call it x. The difference of the two numbers is 18. So I'd have something like x minus y equals 18. We've already called the first number x, so I'm going to solve this equation for y to get an expression that represents the other number. I'll subtract x over and then divide everything by -1. That's going to give me y equals negative 18 plus x. I prefer to write that x minus 18. So that expression, x minus 18, is going to be my second number. Now we need to write ourselves an equation. We're finding two's number whose product is a minimum. Since the product is what is the minimum, we need the product to be our equation. We know product just means multiply together. I'm going to use P of x for product. So P of x is equal to x times x minus 18. We know that the minimum is going to occur at the vertex, so I need to get this multiplied out so I can identify A and B to plug into my vertex formula. P of x equals x squared minus 18x. We need to decide whether we're looking for the x or y coordinate of the vertex. Although it's the product that is a minimum, we're being asked to find two numbers. And if you look to the side here, where we have defined our two numbers, it's x that's showing up. In this application, we're looking for the x coordinate of the vertex. If they were actually looking for what the minimum product was, then we'd be looking for the y coordinate of the vertex. But they're asking us to find two numbers, and we used x to represent our numbers. The x coordinate of the vertex is negative b divided by 2a. So that'll be negative 18 over 2 times 1. That's 18 over 2, which is 9. We found the x coordinate of the vertex. I need to make sure that it makes sense for the context of the application. We're being asked to find two numbers. Is 9 a number? Sure it is. There's no restriction on the type of number. So it's fine that our first number is 9. But we need to actually answer the question. It said find two numbers. So let's answer the question, ATQ. The first number is going to be x, which is equal to 9. And then our second number is x minus 18. So that's going to be 9 minus 18, which gives us negative 9. So our two numbers are 9 and negative 9. You can always check yourselves to make sure that you have the right answer. It said that these two numbers, the difference is 18. So 9 minus a negative 9 turns into 9 plus 9, which is indeed our 18. The maximum or minimum always occurs at the vertex of a quadratic function.